This is a very interesting question. So find the relation in the acceleration of the three masses. So there are three masses A, B, C, and each having acceleration A1, A2 and A3 respectively. And we are supposed to find out what is the relationship between A1, A2 and A3. So in order to find out the relationship between the three masses, it is required you understand the concept of work energy theorem, okay, because that is one of the best and shortcut method to solve these type of question. So this will be based on work energy theorem. So the work energy theorem states that work done by the internal forces is always zero. So we can state this as work done by the internal forces is always zero. And in these type of questions, tension is the internal force. So it means work done by the tension will be equal to zero. So we can write that herein tension, which is represented by T, is the internal force, thus work done by it will be zero. This is basically the work energy theorem. So let us find out the various. So let us suppose T is the tension in this part of the string, and this is a continuous string, so this will be also having a tension of T, and this tension of T will be equally divided between these two tensions. So these two string rather, so this will be T by 2 and this will be also T by 2, and this is a continuous string, so we can say tension here will be also T by 2, and the T by 2 and this T by 2, this will be making sure the tension here is represented by T. Okay, so there is no hard and fast rule in finding out the tensions. So basically what we do, we can start by taking any of the string and subsequently follow to the end of the string. So the same string, if there is no break point, has the same tension. Like for A, this is a continuous string up till here, so this is going to have a tension of T, so this will be also having a tension of T. Similarly from B, this entire is a continuous string, but at this pulley we can say, let us call this as X, Y and Z pulley. So Y pulley has a tension of T, so the subdivided tensions will be T by 2 and T by 2. This is a continuous string which goes across Z, leading to a tension T by 2, and the mass C is going to have a tension T, so indirectly we can find out the various tension across the pulleys as well as along the masses. So let us take the masses one by one. So we can say that for mass A, we have tension T, and A1 is the acceleration in the downward direction, and let us suppose dx1 is the partial displacement of the mass A. Similarly, we can write for mass B We can say that for mass B, tension is given as T by 2, having acceleration A2 in the downward direction, and we can say that there is a partial displacement in upward direction dx2, and finally for mass C, we have a tension T, acceleration A3 is in the downward direction, and let us suppose it is having a displacement dx3 in the upward direction. So according to the work energy theorem, we can say that the equation be given as tension Tx1 plus tension T by 2 dx2 plus mass C is given as T dx3 is equal to 0. We take T as a common and subsequently 2 as LCM, so we get this as 2x1 plus dx2 plus dx3 is equal to 0, and taking, you can say, double derivative, let us call this as equation 1. Okay, taking double derivative of equation 1, we get this as 2a1 plus a2 plus a3 will be equal to 0, and we have not taken the sign here because in each case, if we want to consider the sign, we have to consider the sign negative. You can take it as common. The negative sign is because the acceleration and displacement are in opposite direction. Okay, therefore the negative sign. So we take negative sign as common, or you can simply write this as 2a1 plus a2 plus a3 is equal to 0. So this is a relationship between the acceleration of the three masses A1, masses A, B and C, and the relationship is given as 2a1 plus a2 plus a3. Okay, so this is the complete question. Thank you.